Shows you some of the photographs. This is a view looking towards the exit towards the staircase. This is a view from the staircase looking back into the building, and this is a view down the staircase onto the ground floor. Now, SP conducted some small-scale fire experiments, or quarter-scale fire experiments, as part of the official investigation. They collected temperature and radiative fluxes, smoke optical densities, and toxic gas concentrations. The experimental data, however, did not was not used directly in the evacuation simulation. This was due to scale effects. Remember, they had a quarter-scale experimental setup, and also the fuel used, i.e. Wood cribs, didn't really reflect the material that was burning in the actual disco. So this required, to get over this, we had to do some scaling of the experimental data, and we used some fire modeling to generate a toxic atmosphere based on what we saw in the experiments. And this was done with in deep collaboration with SP. We used CFAST to give us a distribution of smoke, heat, and toxic gases in the compartment. CFAST is developed by NIST, and it's a two-layer zone model. The evacuation modeling made use of toxic gas concentrations generated in the experiments, but scaled up using appropriate scaling factors, and temperatures and radiative fluxes and smoke concentrations derived from the CFAST calculations. We used building exodus to simulate these, and I'm not going to go through building exodus because you've heard enough about that. The hazard data used in exodus, in the exodus simulation, consisted of temperature levels, radiative heat flux, toxic gas. Now, the only toxic gases we had in the calculation were carbon monoxide and carbon dioxide. We didn't have hydrogen cyanide and all the rest of that. So this is going to underestimate the toxicity of the actual situation. We also had oxygen concentrations and smoke optical densities. So all of these were included in the calculations. This gives you an indication of the temperature that we had in the upper layer and in the lower layer as a function of time after the door was opened into the disco room. This gives you some idea of how we broke up the zones inside the evacuation model. We devised 4 zones, and this gives you the temperature in the upper layer. In all zones is obviously the same because we're using a zone model. The temperature in the lower layer is the same. Smoke concentration is the same in all layers. Radiative flux varied in one of the layers, and the various concentrations varied in different parts of the compartment. Oops. It should be noted that the actual fire atmosphere would have contained other toxic gases, as I said, and other irritant gases which would have had an effect, and exodus can in fact include these gases, but as we didn't have reliable data for them, we didn't include them. The door into the fire compartment was opened at 600 seconds after fire initiation, and occupants are assumed to have an instant response time. That is, as soon as the door is open and the flames burst into the room, they take off. That's the assumption that we made. We looked at 3 scenarios. Effectively, scenario A attempts to reproduce the situation. Scenario B looks at a regulatory compliant population. So instead of having 450 people in there, we had 150 people in there. Sorry, instead of 400, we had 150 people. And scenario C looks at the 400 people, but now we've added an additional staircase to see what might have happened. To give you the results very briefly, this scenario A, remember this is the incident that tries to reproduce the original incident. The total evacuation time is about 5 minutes 17 seconds. If we tried, that's with the fire in there, if we evacuated the entire building without the fire, it would have taken about 7 minutes 34 seconds. The average personal evacuation time, that's the average time for an individual to evacuate, was about 2 minutes 46 seconds. The average cumulative wait time, this is a parameter that Exodus calculates, how long you spend or waste in congestion, was about 2 minutes 13 seconds. And so the average, 80% of the average person's evacuation time was wasted in congestion. And this immediately, we use these parameters to give us a feel for the quality of the evacuation. And because this is an 80% case, this is a terrible evacuation situation. The average number of fatalities that exodus predicted for these simulations was 96. Remember, exodus is a stochastic model. We have to run it a number of times, and we get a distribution of evacuation times and the number of fatalities. On average, we got 96 fatalities. These are some clips from the VR work showing the people trying to get out of the exit. These guys with rotating H's and T's above their heads, they're suffering from, they're getting close to, well, they're getting serious levels of toxic gas inhalation or radiative heat exposure and so on. So you can see some of these guys are getting heavily exposed. You can see the chalk marks on the ground. A number of people have already died in the simulation. And this shows you the final body distribution, where we're predicting the bodies are. This is the last person to die in the simulation. And in fact, the bodies are piled up in the simulation. We have bodies piling up due to the situation. Here we're seeing the evacuation depicted in Exodus using the population density mode. Where it's red, you've got in excess of 4 people per square meter. And you can see very quickly the thing gets packed out. It's a very slow process getting these people out. You can see that there are bodies there. Within the actual Exodus software, people moving over bodies are slowed down, and they'll try to avoid, they actually try to avoid walking on a body, but if they can't, they will continue walking over them. You can see the people trying to get out of the exit, and even the people down the staircase are they've still got quite serious doses of toxic product. We predict that the first 150 people to evacuate did so without suffering severe exposure to heat. That is, the fractional effective dose that they received of heat was close to 0. And they only had light exposure to the narcotic gases. On average, the FIN was about 0.07. 41 survivors were likely to have suffered severe burns. That we determined that by the level of FIH that they received. And about 150 to 160 of the survivors we predict would have some form of injury, depending on the level of FIH and FIN that they had sustained. This shows you the body locations. This is showing you where the fatalities started from. And the thing to note is the fatalities were initially distributed throughout the floor. So it wasn't simply the people that were closest to the fire that ended up as fatalities. This is showing you where the bodies are, and this is showing you the number of bodies piled up in these various locations. And so in some places, we're getting about 7 bodies piled up roundabout on top of each other. The firefighters who came in reported in the incident that their access to the hall was blocked by a wall of bodies inside the doorway that reached the top of the door jamb. This is the report from the firefighters going in. And we're seeing that sort of thing developing here.